Now see here. Should have drawn a bit properly. It's the same only. There's no much change. I'm just drawing it properly. That's it. This is a point O. Point say P. Instead of saying P1, take it as Q1. So from P, if this is my coordinate x comma y, and the coordinates of this is x1 comma y1. So the height of this will be y. At this point, this is the origin. So the coordinates for this at a point O will be 0 comma 0. Now see here, what is the concept? And this OP is my arc length. I'm going to take the complete thing. I'm not taking a small part of it. So this I'm calling it as S, where S is nothing but the arc length. Now to start with the explanation part. Okay, what is the question being said? Find the path. Okay. Find the path in which a particle, in the absence of friction. I have told you why this word is being used. Friction, because the path what it is going to travel, it is a smooth path. Friction, when a friction will arise, when this path what you have, no, this path, if this is very rough, there are chances that it will get friction. And why didn't I take a rough, why I have not taken a rough path? Suppose if there is a rough path, it will not trace this proper this curve. Instead it will, if there is a any if it is very rough, it may go like this. Instead of going like this, then with a bump it will go like this. It may come like this, so it becomes very difficult to us to solve, to get a proper curve. So instead what we have said is, in the absence of friction means the curve, the particle is going to travel exactly in this way. It will have a very smooth curve. The particle will never fall in this way. It will take a proper slide. Now what we have to do is, what is a minimum time it is going to take? See here, from one point to another, in the shortest time, I am supposed to find the shortest time that the particle is going to take from this point till the point say Q. Now I'm not going to take from O to Q directly. Instead, first let me solve from O to P, get a value. Once I'm done with that, I'll take integration from O to Q. O to Q means it will be from 0 to x1. Getting the point, everyone? Hello, is this clear? So how should I start? One more thing, once we are considering all this thing, very important point is, here from a point the particle is going to slide from O to P, so it is moving. Now what type of energy do we have over here? What type of energy we expect? Hello, what type of energy do you expect when it's moving? Okay, at this point the particle is not moving, it is stationary. So what do you say about this? Hello,
Potential energy.
at this point it is potential energy at a point O. Now what about from O to P? What about from O to P?
Find
Which energy is that? Particle which is moving from O to P. What will be the work done? Can anyone tell me? Hello? See, this is your kinetic energy or no? Why it is kinetic energy? Because it is a work. See, from this point O to point P. I've said you I'm not going to go to point Q right now. First, let me solve from O to P. Once I get a proper result, then I will say that the total time required for our particle to move from O to Q, I'll take it with integration. Now, once I'm saying the work done for a particle to move from O to P will be difference in the kinetic energy at a point, say P minus O. That is difference. What is the kinetic energy at this point? It is zero. What is the kinetic energy at this point? What will be the kinetic energy? How is kinetic energy defined?
half mv square.
Half mv square. At this point, the particle is not moving. So what do we say? Which energy is over here? At this point, the particle is stationary. So what energy do we expect over here?
Potential energy.
How is potential energy defined as?
M into G into H.
What is H?
H is 0.
No, no. H at, see, when you are saying potential energy, height is also there, no? What is the height? We are taking only from O to P. So height is there, no? What is my height? Why? Clear with this? Okay. So that is what explanation we are. First, to start with the explanation, what should be my very first point? How should I start with? You should write everything of your own, nothing you are going to bahart in this. Okay, how should we start? What is the concept of this diagram? That there is a particle, okay, which is at the point O. It is going to slide along the curve OQ, right? So what are the things? This is what I'm going to write even the explanation. Let P x comma y be any point, okay, and everything whatever I'm doing, it is with respect to time. This thing is happening with respect, we have to find the shortest time, no? So let P be any point on the curve. Okay, so what is my OP? OP is equal to S. This is what I'm going to write. So the particle, let the particle slide along the curve OQ, starting from O. So O means it is the initial point. No, you did not have to explain this. The point O. Now what I have said this O to Q. What is the next thing? I'm introducing a point P. So what is that point P? Let P x comma y be any point, be any point. Let instead of saying that, we will say in this. I can include all the statements only. Let the particle be at a point, say P x comma y at any time, say T. So everything I've covered in one step, such that OP is equal to S. What is that S? Is the arc length. Now, explanation part is over. Do you think any other part is being left out? Everything O is defined, P is defined, as well as Q is also defined. Now, what I have to do? Now, start by the principle of work and energy. The work done. Now, this you are going to do. You are going to answer me. The work done. See, what is the work done in moving the particle from O to the point P? What does that equal to? In moving the particle, can anyone tell me, in moving the particle from O to P, what is that equal to? is equal to what? Hmm. It is moving. No, you are allowing a particle to slide from a curve from a point O to a point P. So what is it? It is the difference in kinetic energy. Is it fine if I write Ke? Understood, it is kinetic energy at P equal to and at O. Work done in moving the particle from O to P is equal to the difference in kinetic energy at P and at O. This is better. What way is the work done over here then in this case? Here, what is the work done? See, the total work done to move the particle from O to P is difference in the kinetic energy. Why only kinetic energy I am taking? Because there is no potential energy. As there is a movement, the particle is moving, so it has to be kinetic energy. And at a point O here, it is only potential energy. We don't have kinetic energy because at this point the particle is at rest. So what do we write? What should be the left hand side? Anyone? Can anyone tell me what should be the left hand side? At a point O, can you tell me right hand side is equal to difference in the kinetic energy at P minus the kinetic energy at O. Can you tell me what is on the left hand side? What is the total work done then at a point O? At this point, what is the total work done? Hello? Can anyone answer me this? Hello? Okay. At a point O, what it is at rest. So what type of energy do you expect? Hello? What type of energy do you expect at that point? Hello?
Ma'am, it's potential.
Yeah, that is what I'm stressing more on. It is potential energy. What is potential energy given by mgh is equal to half here half kinetic energy at P is half mv square. Kinetic energy at a point O is 0. Now what is this value? M G H value is y. Is the height y? Check. Is the value of hy height the total height from O to P? Is it y or no? So I've substituted the value is equal to half m v square. What is the value of v? Can anyone tell me? How do you define velocity? How do you define velocity? It is ds by dt. Where, hello, is it ds by dt or no? So 1m gets cancelled over here. Now what do we have? What is ds by dt from this implies ds by dt is equal to 2gy as it is square. We'll have square root of 2gy here, where v is the velocity of the particle. If you are using any other variable, other thing, you have to mention that is the velocity of the particle at point P, x comma y. Now I have got the value of ds by dt. Call this as equation number 1. Now, therefore, now I'm going to take the total. Hence, the time required by a particle to move from, say, T, to move from, now what point I should take? To move from what I have to say? O to what? O to, hello? I should take from what? O to what? Can anyone tell me O to? Hello? Can you answer me? It has to be P or Q. You only answer me this. What it has to be? Hello?
Q.
It has to be very good. It has to be Q. So, what is this equal to? It is from integration 0 to T dt. Okay, 0 to Q dt. So, can you tell me 0 to Q means what is the coordinate? It should be from 0 to what? What is the point Q? So, we are taking the integration from O to Q. So, integration is from 0 to x1 or no? 0 to x1, right? So dt, can I write this dt as dt dx into dx? Can I write this? Does it make any difference? Now again use a chain rule. It is dt by ds into ds by dx into dx. The reason to do this is I can substitute the value of this as well as this part. Now, since ds, we have got it here. Since ds by dt is root of 2gy, what is dt by ds? 2gy. This implies dt by ds is equal to what? 1 upon root of 2gy. Now also, ds by dx is what? It is root of 1 plus y dash square. Now substituting this value, what do we get? T is equal to integration from 0 to x1 dt by ds is 1 upon root of 2gy and ds by dx is root of 1 plus y dash square into dx. Check. I'm dt by ds, I'm substituting the value this. ds by dx is this. So t is equal to root of 2g is constant which can be taken out. Root of 2g, integration is from x0 to x1, root of 1 plus y dash square divided by y into dx. Now what is the question? We need to find the value of y of x such that your t is minimum. Again it comes under Euler's equation. We have to use calculus of variation. Now what I'm saying, we need to find y of x such that capital T is minimum. So what do we use? We will use a Euler's equation. Now for this, let, what is my f now? As this is constant, 1 upon root of 2g is constant. So what I have, it is root of 1 plus y dash square divided by root of y. It is independent of what?
X.
It is independent of, it is independent of what?
X, ma'am.
So if it is independent of x, then what is the equation? It is independent of x. So now, as it is independent of x, what do we have? It is f minus y dash dou f by dou y dash is equal to a constant, say c. Now, what is here only I'll find what is, need to find the value of f. F is equal to root of 1 plus y dash square root of y. What is dou f by dou y dash then? Dou f, it is partial. Remember that dou f by dou y dash, when I'm saying 1 upon root of y is constant, which is taken out, and differentiation of this root is 1 upon 2 root of 1 plus y dash square into 2y dash. So 2 and 2 gets cancelled. Now substituting in 2, we get value of f is what? Root of 1 plus y dash square divided by root of y minus y dash. Dou f by dou y dash is what? Y dash root of y root of 1 plus y dash square is equal to a constant c. What is the LCM? LCM is root of y into root of 1 plus y dash square. So this will be what? In that case, this is 1 plus y dash square, because you are multiplying this by root, minus y square is equal to c. So y square and y square gets cancelled. Y dash square actually it is. So what do we get? 1 divided by root of y into root of 1 plus y dash square is equal to c. Now, so root of y into 1 plus y dash square, I can also write, is equal to 1 upon c, which I can write as at root of c1. Let me call this as constant. No, I can call it as c1. Reason, so that when I square, I will not get anything with square and all. I'll directly get the constant on both sides. Is y into 1 plus y dash square is equal to c1. Now in this, find what is y dash square. So y dash square is equal to c1, or instead we'll take a, instead of calling this as c1. A divided by y minus 1, which is equal to a minus y divided by y. So y dash is equal to root of a minus y divided by root of y. What is y dash? Dy by dx is equal to root of a minus y divided by root of y. Separating the variables, we are getting actually dy will be here. All the parts have to be, this will be dx is equal to, it is root of y divided by a minus y into dy. Is that right? Check. This part will go over here and this part will come here. Dx is taken over here. I'm taking dx this side because y is in equation, whereas I'm getting the value of x. Now, when I'm integrating this on integration, it is dx integration of root of y divided by a minus y into dy. Now, the right hand side cannot be integrated. We don't have any formula. Instead, can anyone tell me what should be the substitution for this? What should be the value of y? Can you tell me what should be the substitution? Hello? Check, you are having a. Remember this thing, whenever you are having a minus anything, what should be the substitution? If that is so, see, whenever you take this, whenever you are having anything with a minus y or 1 minus y, you have to take y a, because if you take a common, I will take sine square theta by 2. Why sine square theta by 2? Reason? Can anyone tell me the reason why I'm taking theta by 2? Why I'm taking theta by 2? Can you tell me what equation is this? Equation number I want. Equation number 3. If I take this as a substitution, it becomes a minus a sine square theta. If you take, reason to take sine square theta by 2, because it is in square root. Later we can use a formula. These are the formula. 1 minus cos theta is 2 sine square theta by 2. 1 plus cos theta is 2 cos square theta by 2. Keeping this in your mind. And it is with root, so I'm going for theta by 2. So if I differentiate this, dy is equal to a sine square differentiation 2 sine theta by 2, sine differentiation cos theta by 2, theta by 2 differentiation 1 by 2. Sine of 2 theta, even I'll write this, is 2 sine theta cos theta. Now substituting, it is x is equal to integration of square root of y is what, sorry, a sine square theta by 2 divided by square root of a minus a sine square theta by 2, dy is a sine theta by 2 cos theta by 2 into d theta. Now x plus a constant, say a I have taken of b. Now this is equal to integration root of a sine square theta will be, root of sine square theta is sine theta by 2. And if I take root of a commons here, one more step I'm taking, 1 minus sine square theta is what? What is 1 minus sine square theta by 2? So x is equal to integration root of a gets cancelled. here root of a and here root of a. So it is sine theta by 2. What about this? This is cos square theta by 2. This is cos theta by 2. A sine theta by 2, cos theta by 2. Do you want me to take one more step, or is it understood? The whole thing is under root of a gets cancelled. Root of 1 minus sine square theta is cos square theta. Root of cos square theta is cos theta. So one cos gets cancelled. I will have a is taken out, sine square theta by 2 d theta plus b. Now what is sine square theta by 2 formula now? It is 1 minus cos theta divided by 2 plus b. So a by 2 integration of 1 minus cos theta d theta plus b. So integration is a by 2 theta minus sine theta plus b. Now I need to just find the value of b. That's it. Now what is the value of b? Put theta is equal to 0. If I put theta is equal to, it should be in both the ways, because x I have got through y. If I put theta is equal to 0, what will I get? Is y also equal to 0? Put theta, sine of 0 is 0, so y is 0. If y is 0, what about x? X also will be 0. Then, and we have x also 0. Even the reason is, if theta and y both are 0, we'll have even x also 0, since the curve is, since 0 0 is a point on a curve, on the curve, sir. We start from O, no? O is at the origin. So when x is 0, what will be the value of 0? This implies b is equal to 0. When x is 0, everything is going to be 0. So b is 0, 0. Therefore, what do we get? X is equal to a by 2 theta minus sine theta. And what about y? A sine square theta. Y is a sine square theta by 2. This can be written as what? A 1 minus cos theta divided by 2. So x is equal to a by 2 theta minus sine theta. And how about this? So x is equal to a by 2 theta minus sine theta, and y is equal to a by 2 1 minus cos theta. Taking a by 2 as k, we get x is equal to k theta sine theta, and y is equal to k 1 minus cos theta. Therefore, the equation what you have got, no, these are the parametric form of a cycloid. Have you studied cycloid? Do you know what is the equation? Cycloid comes under the parametric form. Either it may be parametric because you are having x and y. So the required equation of the curve is the parametric form of a cycloid. This is a conclusion. Or else, if you want, you can write that the path, the concluding line. What is in the question? The path in which the particle will slide from, you can write in this way: the path of a particle moving in a plane under the action of gravity, under the action of gravity, the shortest time. Okay, you can write it in this way: the shortest time for a particle to move from one point to another is a cycloid. That's it, and you can conclude your statement. It is lengthy, I do agree that, but still it is very important. One of the very standard example it is. Any doubt? Any doubt? Hello? If there is no doubt, can we move to the next example?
Yes, ma'am.
No doubts, no? This is one of the very standard example. What is the time now? Before hanging chain, just let me know whether we have done one more example where prove that the catenary is a curve which, when rotated about a x-axis, generates a surface of minimum area. Is this done? Check whether this example is done.
Yes, ma'am, it's done.
So actually, the unit is completed in that way. Let me just check. I have covered everything. The unit is completed. So we need to start the next topic, that is sampling. That we will be doing it in the next class then. Okay. We will end up the class over here only. In the next class, we'll be doing unit